we've seen a lot of interesting abstracts submitted to our session, and in particular, we now see that in the quantum cascade laser is really moving into application, remote sensing. We have all kinds of abstracts that use those lasers in the mid-infrared for environmental sensing, remote gas sensing, oxygen pollution, ozone levels being measured remotely in field applications already. So that's very exciting. And that's the next thing on the horizon is coming up. Group 3 nitrides now are really being put to use in ultraviolet LEDs, mid-infrared, mid-UV LEDs for water purification. So those LEDs are being used for point-of-use water purification. You know, that's a highly sensitive topic in most part of the world, that water purity over the next 10, 20 years becomes a big issue. And if you can really purify the water, not centrally, but really at the entrance of every household with a small device that uses UV light, that would be real relevant for people's health and security. Also, we see now emerging trend to use those materials, those nitride materials, for solar cells. High efficiency multi-junction solar cells, efficiencies of 40% now, people pushing it towards 80%. And that may be a feature that one can use of those materials, where you can tune the band gap all across the visible spectrum, from the infrared to the UV. So you could have a junction for each of the photons that you want to absorb and stack them up. And I think that is a very big development now. There's even talk about materials that have a band gap, 2 band gaps within 1 band gap. So this inner band gap state could serve as an intermediary state, and you could tune that probably to get over 50% efficiency. So now those abstracts are coming in. We're very excited about that.